Hi, Calculus 1 students. Okay, so this is actually the challenge problem that you have in the section of definite integrals. What you want to do is to evaluate this. Oops, I forgot the dx. Okay, by interpreting it as an area. Okay, note that in Calculus 2, you will see an integration technique that allows you to do this by finding its antiderivative. But this is more just like a nice puzzle that could be asked for sure in the final exam. So to interpret it as an area, we have to actually sketch the region, right? So this is pretty much step number 1. Okay, sketch the region. Okay, and okay, so sketching the region, how will that look like? Well, we will have like the y-axis, the x-axis, okay? And something interesting is gonna go on here. So let's say we have like 1, 2, 3, 4. 1, 2, 3, 4. It turns out that this is the quarter circle of radius 2. What am I doing with my 4 here? It's of radius 2. Okay, so let's restart this. We're gonna get there. There you go. 1, 2, 1, 2. Okay. So the region is this quarter circle. I should say quarter disk because in reality you want to find the area of this. Okay. How you determine that? Well, okay. You have like x squared plus y squared is equal to 2 squared. Okay. So that's the circle of radius 2. Circle of radius 2. Then when you solve this for y, what you're going to get is y is equal to plus or minus the square root of 4 minus x squared. But by selecting the plus, you select the upper half of the circle. So selecting plus selects the upper half of circle. And the fact that we start at 0, let's actually take note of this. So this is like x equal to 0 and x is equal to 1. So we get that here from the limits of integration. It means that we're going from here to here. Okay, so we're drawing only that portion of the circle. Okay. Oops, this is 2. This is 2, not 1. Okay, so this is perfect. Let's actually sketch 2. 1 is right here. Okay, so what it means is that we're not really interested in this. Okay, we're interested actually only in this region. Okay, so from here to here, this is the region we are interested in. So this is the area. Okay, now to find the area of this region, so find area. I will need to resketch the region for one main reason. It's because I want to decompose it into 2 subregions. You have like 1, 2, and 1, 2. That's still good. Now I want to, still draw the like circle like this, and then still draw the 1 that's right here. What I'm gonna do is I'm gonna split it into by drawing here the circle of radius 2. Okay, so what am I doing in reality? I'm dividing this into a sector. So let's just say that total area is equal the area of sector plus, and then I'll keep the same color code, which is red, the area of this triangle, right? Area of triangle. And you can figure out both quite easily. So let's first have a look at the area of the sector. Okay? So this requires us to find this angle over here. And this is the main part of the problem. Now, this is 1, which means that we know that this length is 1. Okay? So the length of this triangle here is 1. Now, you might remember that this triangle is a very special triangle. So the cosine, so the cosine of this angle will be equal to 1/2. Let's actually color code in purple here. Okay, so cosine of the angle is equal to 1/2, which means that the angle turns out to be pi over 3. Okay, so this angle right here is pi over 3. Let's sketch the angle that's like right above here. So the angle here, maybe call it alpha if you want. Okay, and alpha is going to be pi over 6. And from there, you're good to go because since the cosine is 1, well, actually, even without the cosine, you can figure out that this length is the root of 3. So it means that the total area, let's now write the area of the sector. So the area of the sector is going to be pi over 6, because this is alpha, divided by 2 pi. So whatever fraction of 2 pi we have, then we multiply by the area of the full circle, which is pi times 2 squared. So this is the area of the sector. And you add to this the area of the triangle, which is obviously just base times height divided by 2. So base is 1, height is root 3, and we divide by 2 like this. Okay, let's do some minor simplification before we move on. And this will be our final answer. So here, the pi's will cancel. We will have over 12 at the bottom, but then we will have 4. So we will have pi over 3. So that's going to be the area of this sector right here. Just to make sure, this is 4. Yeah, okay, perfect. And then the area of the triangle, there's nothing we can do. We just leave it like this. Square root of 3 over 2. And this is your final answer. All right, I hope this was helpful. See you either in class or in the next video.